Okay, class. Today is a relatively short lesson, or it seems it would be. It looks like it'd be short since we're going to talk about synthetic division, and this is having to do with polynomials, and that's the chapter anyway, so it makes sense. But we're going to tie into it something called the remainder theorem, and we're going to talk about zeros of polynomial functions. And if you recall, the zeros of any function is when the function, whether it's a parabola or a cubic or a quartic, is where the polynomial crosses the x-axis. So a lot of times you can look for them on a calculator, but we're going to talk about how polynomials, we can do some analytical methods. So to start off with the algorithm, let f and g be polynomials and g be a lesser degree. And so we got two. We got f of x and g of x. When he says that, an example would be f of x could be like a 6th-degree polynomial, and g of x has to be a lower polynomial. So that would be g of x could be x to the second power, quadratic. It could be anything like that, and plus there could be more terms. F at x and g of x of degree 1 or more. They have to be more than 1 degree. It would make sense. If it's not more than 1 degree, then there's you wouldn't have. That's only a line. Of 1 degree is only a line. So there exist unique polynomials q and r, such that what that means is q is a quotient and r is be like a remainder. Okay. F of x is q of x. Back up, not q. Let me back that up. I'll show you why. It's going to be g of x times q of x plus r of x. What does that mean? It's like this. When you take something like a 4, let me do 14, and you're going to divide this by 3. When you get done with the math, you say, how many 3's go into 14? And we say, well, that's 4. 4 times 3 is 12. So there's 2 left over. So we're adding the remainder 2. So this is the similar thing, is this is my f of x being divided by a smaller degree of g of x. When you get done, the quotient is q of x. But then you have the remainder. So plus the remainder of x. So in relationship to this 14 is 14 is equal to 3 times the 4, that's 12, plus the 2 remainder. So 14 equals to 14. So f of x is the inside, and it's equal to, you take what you're dividing by times we call this the quotient, that's why it's a q, and you add r. That's where that formula is coming from. G, because the original problem would have been f of x over g of x. A larger polynomial degreed divided by g of x. That's what's happening in this formula. To avoid errors, use blank as the coefficient for any missing terms. Use a 0 for any coefficients that are missing terms. If you look at this one, this has a third degree, second degree, that's 3, 2, 1, and then this is x to the 0. All the terms are there, so nothing is missing, so I can't show you what he's talking about in here. But, before I do this with synthetic, I'm going to remind you what it was in long division. So it looked like 5x cubed minus 6x squared minus 28x minus 2x. Oh, wait, that didn't, yeah, that was not 2x. It was 2, not with an x. So I just got done writing it and I already forgot. Minus 2. This is being divided by x plus 2. So in the old days, when your teacher taught you this, you hated it. And I understand why. I hate it too. How did we do long division? This is called, I'm going to do long division first. Just one time. I'm not going to do it ever again if I don't have to. You do long division, and you had to make sure that every term was here. X cubed, x squared, x to the 0, x to the 1, and x to the 0. So if not, you got to leave spaces where you put a 0 there. You might remember that. X times what is 5x cubed? Obviously, I need a 5, and I need 2 more x's. When you take x times 5x squared, that's 5x cubed. You want those two to be exactly the same, or you have it wrong. Then you take that was 5x squared times the x. Now you do 5x squared times the 2. That gives me a positive 10x squared. Then, just like any other division, like I did over here, if you remember when I did this over here, I took the top minus the bottom. Well, you do exactly the same thing. The top minus the complete bottom. So 5 minus 5, x cubed minus x cubed, that gives you the 0, which that's what you have to get. If you didn't get a 0, then you did something wrong. Then minus 6x squared minus, that's a minus gets distributed inside, so that gives you minus 6 minus 10, that's a minus 16x squared. Okay, now I bring down the next term. That's minus 28x. And you have to ask yourself the same thing. X times what is a negative 16x squared? Obviously a negative 16, and I'm missing an x. Negative 16x times x is a negative 16x squared. They're the same, so I know I'm doing it right. Negative 16x times a 2 is a negative 32x. You take the top minus the complete bottom. Negative 16 minus minus 16 gives you the 0. You know you're doing it right. Negative 28 minus minus 32 gives me a plus 32. That's going to give me a 4x. Again, I have to ask myself, what times x gives you 4x? A 4. 4 times x is 4x. Well, what did I forget to do? I forgot to bring down my minus 2, so I'll bring it down. 4 times x is 4x. 4 times a 2 is an 8. Subtract the bottom from the top. That gives me the 0, so I know that part's right. Minus 2 minus 8 gives me a negative 10. There's no more terms to bring down. So that would be a remainder of a negative 10. But in polynomial work, and even over here, guys, when I had the remainder 2, that really stood for 4 2/3. That would be what 14 divided by 3 is. It's 4 2/3. So over here, I'm going to write it as 10. So I'm going to go plus the remainder, plus 10 out of x plus 2. Now, I hope I get the same answer. Let's see, did you get the right problem? Negative 6x minus 28. I'm going to have faith that it's right. I'm going to show you synthetic division. So much superior than long division. But synthetic division works only when your bottom term is a binomial, like x plus 2. Here's how you do it. You only use the coefficients. 5, negative 6, negative 28, and negative 2. So you only use those. and I'm dividing by that denominator, I have to actually say, well, what is x actually? So I got to say x plus 2 equals to 0. I'm really dividing by a negative 2. So I'm going to put a negative 2 right here. Now let's see how much easier this is. I should get the same answer, I hope, unless I messed up over there. You bring down the 5, and you take these two and you multiply them together. That's a negative 10. These two multiply to get a negative 10. That answer goes right here, negative 10. Then all you do is add straight down. You don't change any signs. You just add straight down. That's a negative 16. Now you take the negative 2 times the negative 16. That's a positive 32. Now you add straight down. That should give me a 4. Negative 2 times 4 is a negative 8. So I put that there, and I add straight down, and I get a negative 10. Did I have a negative 10 over there? Did I mess up? Yeah, I had a negative 10. See? Okay. That's what you call the remainder right here. Okay? So how do you write your answer? You write your answer as if this started out as a cubic, then the answer has to be 1 less. So it's going to be 5x squared minus 16x plus 4. And I have my remainder, plus the negative 10 over the x plus 2. I think I lost my negative somewhere over here. Did I have it over here? Minus 10. Oh, there it is. Minus 10 over x plus 2. I did have it. Wasn't this so much easier than this? Yeah, I agree with you. But you still need to practice doing it because it's not normal for you. All right. Special case. What is he doing here? X minus k, q, r plus r. Maybe I'm not really sure what he's talking about. For any polynomial f of x and any complex number k, there exists a unique polynomial q of x and the number r such that, well, I guess he's just saying the same thing, is that f of x is your large function that you were, think about it, f of x divided by something x minus k, that's your g. That's your g function. So it's your larger function divided by this 1 degreed piece. Will have to equal, if I divide that, has to equal your qx plus r. That's your quotient plus the remainder. It's the same thing we just did. He's just writing it in a special case with x minus k. The other problem, I didn't write it like that. I wish he'd have given us another problem to practice, but such is life. Remainder theorem. So if you're trying to find a polynomial divided by an x minus k, if the polynomial f of x is divided by x minus k, then the remainder is equal to, well, the remainder should be 0. The remainder should be 0. I'm going to try to do an example with you. Let's see. X squared plus 4x plus 4. I'm going to call that f of x. And I'm going to divide that by an x plus 2. So my g of x will be an x plus 2. So what I really have now, I'm going to do x squared plus 4x plus 4 divided by x plus 2. So there's my polynomial. There's my x minus k. Minus k, so I got to take the opposite. My k must be a negative 2. So long division, it would look like this. X squared plus 4x plus 4 divided by x plus 2. Why don't we do both long division and synthetic just to show you that the remainder will be 0. X times what is x squared? X. X times x, x squared. X times 2 is 2x. Subtract the bottom from the top. X squared minus x squared goes away. 4x minus 2x is still 2x. Bring down the next term, plus 4. x times what is 2x times 2. So 2 times x is 2x. 2 times 2 is 4. Subtract the bottom from the top. 2x minus 2x is 0. 4 minus 4 is 0. So that remainder is 0. You see? So that means this polynomial was evenly divided by this binomial. Still a polynomial of degree 1. Let's do it synthetic. 1, 4, 4 divided by the opposite of x plus 2, that's a minus 2. Because it's x minus k. So x minus minus k gives you the positive. So it's the same thing we've had 100 times now. Bring down the 1, multiply negative 2 goes there, add straight down 2, multiply negative 4, add straight down, you get to 0. So much easier to do synthetic than it is to do long. But anyway, something about the remainder theorem. If you don't get 0, you get a remainder. Interestingly enough, if you want to find out what f of a negative 3 is, that's the same thing as dividing by x plus 3. So if this goes in evenly, you get a remainder of 0. If this doesn't go in evenly, then the answer actually is the remainder, f of a negative 3, will be the remainder. So even if it's 0, f of negative 3 could be 0, or f of a negative 3 could be a negative 10. I don't know what it's going to be. Whatever the remainder is, that's what the evaluation of that function is. So we'll do it with synthetic division. I'm going to take the negative 1, the 3, the negative 4, the negative 5, and divide it by a negative 3. So this is the same as plugging in a negative 3 into the equation. However, I just noticed that I'm missing a term. I do not have a cubic. So I'm going to have to add a 0 to hold the place, because there is 0 x cubed. It will change the answer. So I bring down the negative 1, multiply this times this, gives you positive 3. That answer goes there. Add straight down, that's a 3. Negative 3 times 3 is a negative 9. Add straight down, it's a negative 6. Negative 3 times negative 6 is a positive 18. That answer goes here. Add straight down, that's a 14. Negative 3 times 14 is a negative 42. That answer goes here. Negative 42 minus 5 adds up to a negative 47. If I did it right, then f of a negative 3 should be a negative 47. So let's see if it is. Let me do f of a negative 3. F of a negative 3 the long way would have been a negative of a negative 3 to the 4th plus a 3 times a negative 3 squared minus 4 times a negative 3 minus 5. Okay, so there's a negative out front. And this negative here is to the 4th power, so it goes away because the negative times the negative times the negative is positive. Negative 3 times 3 is 9, times 3 is 27, times 3 is 81. Plus a 3 times a negative 3 times negative 3 is a positive 9. And then a negative 4 times a negative 3, well, it's not a negative 4, it is. Negative 4 times 3 is a positive 12. Then bring down the minus 5. Let's see what happens. Put all the negatives together. Negative 86. That's this one and this one. Plus a 3 times 9, that's a 27. Plus a 12. Okay. Potential zeros. A zero of a polynomial function f of x is a remainder k, is a number k, sorry, such that f of k has to equal to 0. That's the remainder that we had. Real number zeros are the x values of the x-intercepts, or there might be another word they might have, like the real values or something. A zero of f of x is a zero of a function. I'm going to do it my way. I'm not really sure what he wants. A zero of a function is it's a solution, or it can be called an x-intercept of the equation f of x. He may have something else, but the whole point is this. If you have real number solutions and you are taking a polynomial and you're checking if f of some k is equal to 0, if that's true, then that means it was a 0. It was a solution. It's the x value here. That's k right there. Okay. He may have something else, but I'm going to run with. Okay, some practice problems. Got to take it slow here. Decide whether k equals to 1 is a solution, which means that x minus 1 would have been a factor of this trinomial. Kind of interesting to think about that. If x minus 1 is a factor, you could easily factor this cubic much easier than probably most of you at this point. But let's just check it. That's a whole nother story about factoring. Let's just check to see if k could be 1. So that means if I check f of 1 and I get a 0, then the answer is yes. Well, how am I going to do it? I don't want to really do it long way. I'm going to do it with synthetic division. I'm going to take these coefficients. There's a 1. That's negative 4. Make sure you have every single one. 3, 2, 1, 0. Yeah. Negative 4, 9, and a negative 6. Divide it by k is 1. And see what happens. Let's just try it. 1, 1. 1 goes there. Add straight down. Negative 3. 1 times negative 3. Negative 3. Add straight down. 6. 1 times 6 is 6. And lo and behold, it is. That means yes, it is a 0. So if you could graph that cubic, and that cubic we know starts at the bottom, and it has, you know, a 1 turn, 2 turn. That means when it crosses on this side, it's actually crossing here at x is 1. I don't know about the other two. Not right now, I don't. But I do know at k is 1, it crosses the axis there. Graph it with a calculator and check it yourself. Okay, let's do another one. Check the terms. Make sure we have them all. 4, 3. I'm missing the x squared term. So that means there's a 0 in front. Got to be careful. I've made a lot of mistakes by forgetting those missing terms. So I have a 1, 1, a 0. Wait, no, I'm not missing the square term. I'm missing the cube term. I have the 4. I'm sorry. So that one actually goes here. 4. So it's a 1 and then a 0, then a 1, then a negative 3, and then a 1. Fourth power, third power, second power, 1 power, 0 power. Okay. Divide out by a negative 1. Let's see if it works. 1, multiply, put here, add straight down, multiply, put here, add straight down, multiply, negative 2, add straight down, negative 5, I don't think so, 5, add straight down, 6. So the answer is no. x equals to a negative 1 is not a 0. Okay. Those are checking for real numbers. Okay. What if this fourth degree has a complex number as a root? Now, let's see if it is. And this is hard, so bear with me. 4, 3, 2, 1, and there's a negative 5x to the 0. So we have them all. 1, negative 2, 4, 2, negative 5. I'm dividing out by a 1 plus 2i. Okay, this is really hard sometimes. You got to be very careful. So I bring down the 1, and I multiply 1 plus 2i times 1. That's a 1 plus 2i. Next to the 2, there are no i's. So when I add straight down, it's the same thing as adding a negative 2 plus a 0i. So that comes out to a negative 1 plus an I. No, plus 2i. So now I've got 1 plus 2i times negative 1 plus 2i. I don't really know what that is, so I'm going to have to do the math. 1 plus 2i times a negative 1 plus 2i. I don't know the answer, so I got to be very careful here. 1 times 1, negative 1 is a negative 1. That's these two. A 1 times a 1 times a 2i is a 2i. A 2i times a negative 1 is a negative 2i. Then a 2i times a 2i is a 4i squared. That turns into a negative 1. These two cancel. A negative 4 times a negative 1. Remember what I squared is. It's actually a negative 1. So you got to be careful. A negative 1 plus a 4 times a negative 1 is a negative 1 minus 4. That's a negative 5. So that answer, negative 5, goes here, negative 5. And I add straight down. 4 plus a negative 5 is a negative 1. So now I take the negative 1 times 1 plus 2i. That's a negative 1 minus 2i, because that negative 1 has to be multiplied by both terms. Add straight down. 2 minus 1 is simply a 1. 0i minus 2i is a negative 2i. Now I got to take a 1 plus 2i times a 1 minus 2i. 1 plus 2i times 1 minus 2i. Do you remember what that's called? Those are called conjugates. There's a secret. We should know the answer, because the outside and inside should cancel out. But just in case you forgot, 1 times 1 is 1. 1 minus 2i is minus 2i. 2i times 1 is a plus 2i. You see, they do cancel. And a plus 2i times a negative 4i. I'm sorry. A plus 2i times a 2 is a negative 4i squared. So just as I said, these two cancel. And that's a negative 4 times a negative 1. That becomes a positive 4. 1 plus 4, 5. So that 5 goes here. Add straight down is 0. So what can I say? I can say that since k is 1 plus 2i, then the value x equals to 1 plus 2i is a non-real solution. It's a solution, but it's not real. Therefore, it doesn't cross the x-axis here. That doesn't exist on the x-axis. That's in the complex plane, if you recall. Wow, what a monster problem. Okay, we are done with this lesson. So I will expect you to get your My Math Lab done. A day, your My Math Lab will be due on Monday. And B day, yours will be due on Wednesday of next week. Adios. Thank you for being good sports. Problem. Wait, we're done. That continues the lesson about zeros of polynomial, but